On to today's lecture. The big deal about today is it's really the last of the material. I'm going to be finishing up section 4.7. You know, I guess I could have rushed through this stuff and actually made you guys have the test on Thursday, but I decided just to have the test on the following Tuesday and stuff, but that way we got time to get this soak in, especially these optimization questions and stuff like that. So let's come over here. Before I get started on today's awesome lecture, I want to see what you guys see on the Canvas page because I put a lot of stuff up there. Now, first things first, you know, we have our review session, and here is a copy of your link to the homework number 4, test review number 4, which is due on Friday at our review session, at the beginning of our review session, which is at 3:30. This also means your test number 4 will be on Tuesday, May 1st, 2018. And here's some more information. The Math 1241 exam review will be in Fretwell 100 at 9 a.m. on Wednesday, May 2nd. And we will cover and I changed it for you guys, the Math 1241 Fall 2016 exam, because somebody complained in here that I was doing the Spring 2016 exam, and that was actually what the solutions they were selling at the bookstore. Well, I didn't pay attention to that. I just grabbed one out of the lineup and decided to do that one. But because I didn't want to duplicate something that you guys probably already have because you bought it at the bookstore, I changed it because I know you guys don't have the Fall 2016 solution. So we're going to be going over this one, okay? And also, this will be on, like I said, on Friday, on Wednesday, at 9 a.m. in Fretwell 100. But if you've got friends that are in somebody else's section that you would like to invite with you, that your roommates or whatever, you're more than welcome to invite them. But they will not have the link to this thing. You're going to have to print this thing out for them, okay? Because only my class actually has the link for this Fall 2016 exam. Also, very important information here is this. Your Math 1241 final exam will be on Thursday, May the 3rd. And where are we going to be at? Where's our exam at? I'm trying to get you guys to memorize this. Denny 200. We're not going to meet in here. This is final exam, common exam. We're going to be in Denny 200. Okay? Your exam starts at 3 o'clock, which means you got to be at the exam review the exam session actually at 2:30 or 2:35, something like that, because you got to get your seat, you got to get set up. We're going to go ahead and pass out a bunch of information for you. You got a bunch of stuff to fill out. You got to bring your student ID card with you. Whole 9 yards. Big to-doings here. And right at 3 o'clock is when you open your test booklet. And right at 3 o'clock, no one else is allowed to be in the exam. So if you show up late, you'll be thrown out. You're not allowed to come to the exam late. Okay? This is a timed event. You have 3 hours to complete the exam. So it's a common exam, highly regarded. The last thing is, so you got to be there at 2:30. One last thing is this. It's time for the old course evaluation stuff here. And so this is the link for you guys to fill out the course evaluations. I'm sure you got some interesting email from the registrar or whatever about the course. Now, please do fill out the course evaluations because a lot of students don't fill these things out and stuff. And to me, it's real important for multiple reasons. One, I want to know what you guys think of the class, how I can improve it, what you guys thought were great about the class or whatever the case may be. Also, I want you to make comments about especially things like the videos, you know, because I'm fighting with administration big time about keeping the videos in the classroom. Because it's not just you guys using this stuff. I know a lot of other sections that are getting the links to our videos from our classes and stuff and are using these things. And I want the administration to know if you think they're worthy or you think, no, I really didn't use that video. Well, let me know about it. If I can approve them, whatever, let me know about them. But do let the administration know. If you think they're worthy and you really like these concepts and stuff, we're trying to spread the word, not just we should use the videos. Physics department, the chemistry department, you know, I'm trying to get the word out there that these, I think, especially for our large sections, these things have been incredibly helpful. But you guys let me know what you guys think about it. But this is an administration thing, and there's a cost to these videos. And I'm fighting that big battle big time because they always want to cheapen up on us and try something else, or basically because of cost, I'm sorry, this is not cost effectiveness, and we'll completely cut the whole program and stuff like that. So I'm trying to make the administration, come from the provost on down, realize how important these things are. But it's through your course evaluations that they actually see this stuff. I can tell them all day long and they just ignore me to no end. But you're different. You actually pay to come to this school. So you actually have some weight in this thing is what I'm telling you. So please fill out the course evaluations and let them know about it. Okay? All right. So also, let me come over here to, like I said, a lot of information up here at the beginning. I also put one more thing up here on your modules page. As you know, way down here at the bottom, because we're at the end of the semester, here is your test review number 4. And as you know, some as before, I got it all set up in multiple choice. They may randomize the answers and stuff like that. And even on the free response, I've got so you can put in the answers and stuff like that, multiple choice or whatever. Here's our information about the test number 1. Also, test number 4 that is. But I also put information down here on this one. Here's the information about the exam review one more time, but I also posted it on the front page. But this one's new. This one's your Math 1241 Final Exam Review Information to Study. So I click on this guy here, and what I did was I posted some old final exams. I got Spring 2014, Fall 2013, Fall 2012, Spring 2012, blank exams. You guys can see what the exams look like, and right below it, a video solution where I actually, that particular semester, that's the exam I covered, and I went through the entire exam showing you guys what the answers are, not just answers A. I actually went through every problem in great detail to show you what the answer is, also to show you can do this stuff in 3 hours. So it's quite a bit of information right here, but it's real helpful. So don't just, when you're preparing for the final exam, just don't walk in this thing cold. You need to prepare for a common final exam. And the best way to prepare for a common final exam is to get yourself access to old common exams and see how the structure is and be very familiar with it. And that's what I'm doing for you guys here, because I've got the old exams and I got a solution, video solution. And because a lot of people ask me, oh, Dr. Taylor, can't you just print out what that stuff you wrote up so I can just look at it and say, yes, I can do that. But I've learned through the years that when I give you guys just a solutions handwritten, you guys just look at the answer for the most part and actually don't dive deep in terms of the problem and the nuance of the problem. By making a video solution, well, I'm more forcing you to actually go through the problem. Now, you can skip through it and see what answer I circled at the end of the problem. Yeah, you can do that. But when you actually watch the answer, me doing it and stuff, hopefully that stuff will sink in a little bit better. Okay? All right. We are in section 4.7, the last section of Calculus 1, and the beginning section of Calculus 2, let you guys know. Now, I wrote it for you guys last time, the antiderivative or integral rules that you were supposed to have memorized. And I went out of my way to say, hey, before you guys come to class on Tuesday here, make sure you got this stuff memorized. Now, what's going to make this test tough, this test number 4 tough for you guys, is we're doing a combination of derivatives, optimization, take derivative, set equals 0 and solve, and all those wonderful derivative rules. At the same time, we're going to be doing the antiderivative stuff. And the formulas are similar, but backwards. And if you get confused, it's not going to make a very happy day for you on test number 4. You've got to make sure. Derivatives, take derivative, that's a left brain thing. Antiderivatives, right brain thing. And don't let your brains mix up here. Focus on derivatives and then focus on antiderivatives and don't get your formulas backwards. That's where most folks will mess up, is they'll get the formulas confused. They meant to take the derivative of x cubed and they went x to the 4th over 4. No, dude, that's the antiderivative. You went the wrong way. Derivative of x cubed is 3x squared. You know, make sure you know when you're going in the right direction. So just to remind you guys, in terms of rules, the integral of the derivative is the original function up to a constant plus c. Also, the derivative of a little f of x dx, by definition, is going to be big f of x plus c. The basic rules, the integral of a constant dx will be a constant times x plus c. If it was the integral of a constant dt, that would be a constant times t plus c. Basic rule. Integral of x to the n dx is equal to x to the, instead of the derivative where you put the exponent out front, to do the opposite of that, you add 1 to the exponent and divide by that same exponent. X to the n plus 1 over n plus 1 plus c. Some of my basic rules: integral of e to the x is e to the x plus c. Integral of a to the x, something other than e, will be a to the x divided by the natural log of a, divided by the adjusting factor, natural log of a, plus c. Here's the big rule right here: the integral of 1 over x dx is equal to the natural log absolute value of x plus c. And basically back here, this rule, the integral of x to the n dx, works for as long as n doesn't equal negative 1. X to the negative 1 is the same thing as 1 over x. So this is a special rule for this guy here. This x to the n, called the power rule, works for all powers except negative 1. Yeah, Cole?
If that was 5 instead, would that be 5 natural log for natural log of x?
What do you mean, this one down here?
Yeah, that was a 5 on top.
I mean, okay, yeah, oh yes. Rule 1, with derivatives, where do constants get to go? Out front. Antiderivatives, same rule. Constants go out front. So if I had the integral of 5 over x dx, 5 is a constant being multiplied. You can pull them out front. That would be 5 times integral 1 over x dx. And that would be 5 times natural log absolute value of x plus c. Constants get to go out front. And here's some of my special rules. The integral of 1 over 1 plus x squared dx is the arc tangent, just writing those arc tangent rule in reverse, plus c. The integral of 1 over the square root of 1 plus 1 minus x squared dx is the arc sine of x. There was one more I should have written down. The integral of 1 over x times the square root of x squared minus 1 dx is equal to the arc secant of x plus c. And then you got your 6 trig rules here. The integral of the cosine of x dx is equal to the sine of x plus c. The integral of the sine of x dx is equal to negative cosine of x plus c. The integral of secant squared of x dx is equal to the tangent of x plus c. The integral of secant of x tangent of x dx is secant of x plus c. The integral of cosecant of x cotangent of x dx is negative cosecant of x plus c. And the last one, the integral of cosecant squared of x dx is negative cotangent of x plus c. Now honestly, in terms of memorizing this stuff, if you look at how I wrote this stuff up, all I did was ask you what the derivative is and wrote it in reverse. The derivative of sine of x is cosine of x. Therefore, the integral of cosine of x dx is sine of x plus c in reverse. The derivative of cosine of x is negative sine of x. So therefore, the integral of sine of x dx is equal to negative cosine of x plus c. I just moved the negative to the other side. The derivative of tangent of x is secant squared of x. Therefore, the integral of secant squared of x dx is tangent of x plus c. The derivative of secant of x is secant of x tangent of x. Hence, the integral of secant of x tangent of x dx is secant of x plus c. The integral of cosecant of x cotangent of x dx, for the same reason, is negative cosecant of x plus c. And since the derivative of cotangent of x is negative cosecant squared, therefore the integral of cosecant squared of x dx is equal to the negative cotangent of x plus c. These are the basic rules you need to have memorized. And so let's start doing some bunch of problems, because there's still really 3 different kinds of problems they're going to ask you about this stuff. Now, over here, and our first page is over here. So I did a bunch of problems on the video, so let's pick it up with problem number 7 right here. Blow it up for you guys in the back. So please, and take notes of those pre-section videos that I've done. All right. Read or listen to the directions, because they're going to be the exact same directions what's on the test number 4 and the final exam. The directions are going to very clearly say, take the antiderivative, especially on the final exam. They like to use the word antiderivative, but since I'm trying to prepare you guys for Calculus 2, also the word integral or integrate means the same thing as antiderivative. So it says, take the antiderivative of f of x, which is equal to 2x cubed minus 7x squared plus 7x minus 7. Antiderivative means integrate the function 2x cubed minus 7x squared plus 7x minus 7 dx. 2 is a constant. Constants hold over. Antiderivative or integral. X to a power, you add 1 over add 1. So the integral of x cubed would be x to the 4th over 4. Don't worry, I'll go back later and clean them up. Minus 7's a constant, leave him alone. Integral of x squared, x to a power, add 1 over add 1, gives me x cubed over 3. plus 7x, 7's a constant. This officially is x to the first power, but he's still x to a power. So to integrate, you add 1 over add 1. That'll give you x squared over 2 minus, this is a special rule. What's the integral of 7 with respect to x? 7 times x. And officially, every time you integrate, you get a plus constant of integration. But a constant plus a constant plus a constant plus a constant is one big plus c at the end. So the last thing you want to do, of course, is clean this thing up. So when I clean this up, I get 2 divided by 4, which is a half. So this is x to the 4th divided by 2 minus 7/3 x cubed plus 7/2 x squared minus 7x plus c. And if they put it as a multiple choice kind of answer, that's how they would write it up. Does that make sense? Don't lose you guys anywhere. Okay? Turn page. Now, if you'll notice in this section, we beat to death that power rule. We love that power rule. But the deal about the power rule, the integral of x to the n dx is x to the n plus 1 over n plus 1 plus c, is there's only one restriction on the power. Can't be -1 because that's a special rule. It can be fractions, it can be negative exponents, it doesn't matter. So here we go. Same directions. Take the antiderivative or integral of this function. So the integral of 6x to the 1/5 minus 18x to the 4/5 dx would be equal to 6 is a constant. Leave it alone. Holds over. Integral x to the 1/5, you add 1. 1 to 1/5 is actually what? 6/5 over 6/5 minus 18 is a constant. Hold it over. Integral x to the 4/5, you add 1. So that'll be x to the, adding 1 to 4/5, adding 1 is 5/5, so that'll be what? 9/5 over 9/5, and then one big old plus c. But like with most calculus, before you circle that answer, clean it up. When I divide by a fraction, I invert and multiply, so that'll be 6 times 5 over 6 x to the 6/5 minus 18 times, dividing by 9 over 5, the same thing as multiplying by 5 over 9, x to the 9/5 plus c. And then I clean it up one more time here. The 6's cancel. I'm left with 5x to the 6/5 minus 9 goes in 18 2 times, and 2 times 5 is 10, x to the 9/5 plus c. And there's my final solution. Does that make sense? Look at the next one. Same directions. Find the antiderivative. So this means integrate. The 7th root of x squared plus 2x to the 2 over x to the 5th plus 1 over x dx. But before you integrate, clean them up. You want to turn them into a rule that you have memorized. We have memorized x to a power, as long as the power is not -1. So this one I'm going to clean up, and this one I'm going to clean up. So this is equal to the integral. I don't do 7th roots. That's a 1/7 power. And 7th root of x squared makes it x to the what? Very good. 2/7 power. I don't do stuff in the denominator. I bring them to the top and make the exponent negative. That would be 2x to the -5. However, 1 over x is a special rule, so I'm going to leave him alone and not clean him up because I got that rule memorized. So now let's integrate. Add 1 over add 1, power rule. So the integral x to the 2/7 add 1, which is 7 over 7. That'll give you x to the 9 over 7 over 9 over 7. Plus 2, integral x to the -5, add 1, that'll be x to the -4 over -4. Plus the integral of 1 over x, that's my special rule. What is it? Natural log absolute value of x, and then one big old plus c. But of course, we're going to make you, especially on the multiple choice kind of answers, we're going to make you clean this stuff up. So when I divide by a fraction, invert and multiply, so the answer would have been 7/9 x to the 9/7. Positive divided by a negative is a negative. 2 goes in the 4 2 times. Negative exponent is on the bottom. And when everybody moves, you still have 1 for placement. So it's 7/9 x to the 9/7 minus 1 over 2x to the 4th plus the natural log absolute value of x plus c. And I'm making you go through the gamut of, you know, if I didn't tell you to clean up the answer, this would have been fine, and even web work will accept this answer. But I'm trying to set you guys up for a multiple choice kind of test here. This is how the multiple choice answer would have been. Okay? Well, how many of you guys have signed up for Calc 2 next semester? How many of you guys have signed up for me for Calc 2 next semester? Oh my goodness, I must have lost half my class here. I'm sorry. Wow, I must have kind of made you mad or something, brother. I don't know. Okay. So, but regardless, whoever your professor is next semester, never forget, as long as you live, when you're 90 years old, someone's going to ask you this. What was John's fundamental theorem of calculus? What is John's fundamental theorem of calculus? It's better to clean up your algebra before your calculus than afterwards. So when you get a problem like this, notice when it comes to integrals, we do not have a quotient rule. We do not have a product rule. We have basic rules. So if I'm doing a quotient or a product, if I got a product, I'm going to fall that stuff out. If I got a quotient, I got to clean it up. This is a quotient problem. So they're asking me to integrate x to the fourth plus h squared of x over x squared with respect to x. So integrate this guy. So integral, there's the function, dx, because x is the variable. But because we're dividing by a single term, we can clean that up. This is the integral of x to the fourth over x squared plus 8. I don't do square roots. That'll be x to the 1/2 over x squared dx. And now clean it up even more because, you know, x to the fourth divided by x squared cleans up and becomes what? X squared plus 8's a constant over x to the 1/2 divided by x squared. When you divide, you subtract exponents. A half minus 2 is negative 3/2, negative 1/2 dx. Now, honestly, I haven't really done anything to the problem except clean him up, but I put him into a fashion that is a formula I have memorized. What's the integral of x to the square? Add 1 over add 1, I get x cubed over 3 plus 8. What's the integral of x to the negative 3/2? Add 1, x to the, what is negative 3/2 plus 1? Negative 1/2 over negative 1/2, and then one big old plus c. But now you want to clean it up. Well, x cubed over 3 is pretty much cleaned up there. But a positive divided by a negative is a negative. When I divide by a fraction, I invert and multiply, so the 2 goes on top, and 2 times 8 is 16. But a negative exponent goes on the bottom. And again, for multiple choice answers, that'll be x to the 1/2 on the bottom, but a half a power is a square root. And then plus c. There's my answer. Does that make sense? This problem right here is where most people are going to die if they die on this stuff, because they're going to get those derivative rules and integrals backwards. The question is, what is the antiderivative or integral? So I'm going to integrate 9 sine of x minus 8 cosine of x plus secant squared of x dx. When you integrate, things are being added, subtracted. You integrate each term. The first term is 9 sine of x. Hold the 9. What's the integral of sine? Is it negative cosine or positive cosine? There it is right there. Because you and I both know, in terms of multiple choice answers, we're going to put both of them on there. And you're right. One of them's right, one of them's wrong. What's the derivative of sine of x? Cosine of x. Therefore, when you go in reverse, and if the derivative is negative, the antiderivative is going to be the opposite of that. So the derivative of sine of x is cosine of x. Memorize that. So therefore, what's the integral of sine of x? Negative cosine of x. Minus 8. What is the integral of cosine of x? Sine of x or negative sine of x? Sine of x. The derivative of cosine of x is negative sine of x. Therefore, the integral of cosine of x is positive sine of x. It's the same thing, but the opposite sign. There's a pattern here. Kinematics, catch one. This is pure memorization. What's the integral of secant squared of x? In other words, derivative of what function gives me secant squared of x? That's when you got a tangent of x. and then one big old plus c, and then cleaning up for the answer. 9 times a negative cosine is negative 9 cosine of x minus 8 sine of x plus tangent of x plus c. There's my answer. But you and I both know on multiple choice answers, there's one answer. The other answer is going to be positive 9 cosine of x plus 8 sine of x plus tangent of x plus c. And then every combination of negative and positives you can think of will be in your lineup for A through E. You got to make sure you know your signs. Look at number 12 here. Directions. Find the integral or antiderivative of this function. The integral of negative 2 divided by the square root of 1 minus x squared dx. Negative 2 is a constant in the numerator. Constants do what? They go out front and hold over. So this is equal to negative 2 times integral of 1 over the square root of 1 minus x squared dx. And I wrote this problem like this so you can see the formula that you're supposed to have memorized. What's the integral of 1 over the square root of 1 minus x squared dx? What's the integral of that? Arc sine. Very good. So this is negative 2 times the arc sine of x plus c. Pure memorization. You either know it or you don't. And if you don't, it's always next semester. Okay. I'm trying to tell you, memorize this stuff. This is calc. It only gets worse in calc 2 to let you know about memorization. Does that make sense? All right. So, that being said, what are some other ways except take the antiderivative or integrate that they can ask you questions about? Here is, and again, now at this point on, it's all about the directions and again, what we're expecting you to do. Look at the directions on this one, number 13. Find the function big F of x, given that little f of x is equal to 2x to the 7th minus 4x cubed, and big F of 0 equals 19. This uses the notation that big F of x is equal to the integral of little f of x dx. It uses that notation. Okay? So, big F of x would be equal to the integral of 2x to the 7th minus 4x cubed, and then dx, because x is your variable. So, big F of x is equal to, 2 is a constant, holds over. What's the integral x to the 7th? Add 1 over add 1, x to the 8 over 8. Minus 4 is a constant, holds over. What's the integral of x cubed? X to the add 1, 4 over 4. Then what? Don't forget, with antiderivatives, what you got to put? Plus c, because the integral of 0 is some arbitrary constant. And everything has 0 added to it. So let's clean them up, and we get this. Big F of x is equal to, 2 goes in 8 4 times. That'll be x to the 8th divided by 4. Here the 4's cancel. Minus x to the 4th plus c. There is almost my answer. Except here's the deal. They gave you one other piece of the puzzle. And that piece of the puzzle is what we call initial condition. You're going to see this a lot when we get you guys into especially something called differential equations. This idea of an initial condition has got one job, is to help you figure out what that constant should have been so you can get the exact function. So you can get the general antiderivative, and then with the initial condition, you can actually figure out what that plus c is. This means f of big F of 0 is equal to 19. So, big F of 0, I'm going to plug in 0 for all the x's. 0 to the 8th divided by 4 minus 0 to the 4th plus c, but that's supposed to be equal to 19. The job of the initial condition is to solve for plus c. Okay? Well, this one's nice because 0 to any power is 0. That goes away, minus 0 that goes away. This pretty much tells me c equals 19. Therefore, and 3 dots in a triangular fashion means therefore, the big function, big F of x, is actually equal to x to the 8th divided by 4 minus x to the 4th plus c, but c is 19 in this problem. And there is the unique function that has this as its this as its derivative, and it goes through this particular point. This initial condition's job is one thing: solve for c at the end of the problem, so you know what the specific function is. Now, how can they turn up the heat on you guys? Take a look at this next one. It says this: find the function f of x, given that f double prime of x is equal to 24x squared plus 10. F of 0 equals 5, and f prime of 1 is equal to 2. All right. This is taking the concept one step further. What did they give you in this problem? F double prime of x. So here's the idea. When I integrate f double prime of x dx, you know what you get? When you integrate, and it kills rid of one of your derivatives, you still got one derivative left over. Plus c, of course. And this initial condition will help me figure out the c here. And then you got to integrate f prime of x dx so you can get to the original function plus c. And this information is going to help me figure out what the c is here. So basically what you're beginning to do is what we call double integrals. You got to integrate this sucker twice because you got the second derivative and they want the original function back. Every time I integrate or take an antiderivative, it gives off one of my derivatives. So when you got a second derivative, I got to integrate it twice to get the original function back. So here we go. To get f prime of x, I've got to integrate the second derivative. That will be the integral of 24x squared plus 10 dx. 24 is a constant, leave it alone. Integral of x squared, add 1 over add 1, is x cubed over 3. Plus the integral of 10 with respect to x is 10x. And then, of course, every time you integrate, you got plus c. Cleaning it up, this tells me f prime of x is equal to 24 divided by 3 is what? 8. X cubed plus 10x plus c. I cleaned them up, but now I have a plus c. I have to use its initial condition to figure out what that c is. The initial condition for the derivative is f prime of 1 is equal to 2. So f prime of 1 would be 8 times 1 cubed plus 10 times 1 plus c, but that's got to be equal to 2. Well, it's cleaned up. 1 cubed is 1 times 8 is 8 plus 10 times 1 is 10 plus c equals 2. This gives me 18 plus c equals 2. Subtract 18 from both sides, and I get c to be what? Negative 16. Therefore, f prime of x equals 8x cubed plus 10x plus c, but c is minus 16, so plus negative 16 is minus 16. Does that make sense? Congratulations, you're half done with the problem. Now, I've got to get the original function back. I've got to integrate that answer, the derivative, with respect to x. So the integral of 8x cubed plus 10x minus 16 dx is equal to, here we go. 8's a constant, leave it alone. Integral of x cubed is what? Add 1 over add 1. X to the 4th over 4. Plus 10's a constant. This officially is x to the first power. Integrate, add 1 over add 1. Gives you x squared over 2. Minus, what's the integral of 16 dx? Constant times x, 16x. And then another plus c. So this gives me f of x is equal to 8 divided by 4 is 2. 2x to the 4th plus 10 divided by 2 is 5x squared minus 16x plus c. But now I've got to use the initial condition to figure out what that c is. And they gave me f of 0 equals 5. So f of 0 equals 2 times 0 to the 4th plus 5 times 0 squared minus 16 times 0 plus c, and that's supposed to be equal to 5. Well, I love plugging in 0. In this example, plugging in 0 gives me a bunch of zeros. So that pretty much tells me c equals 5, and therefore your final answer f of x is equal to 2x to the fourth plus 5x squared minus 16x plus c, but c was 5, so plus 5. There's my answer. Does that make sense? Now let's convert this over into a physics-style problem. See how bad they can mess you up. In terms of physics and relations and stuff, your original function is called the position function. When you take the derivative of position, what do you get? What's the derivative of position? Velocity. You get a velocity function. And if I take the derivative of velocity, which is the second derivative of position, what do I get? Acceleration. So please understand what they're trying to get you to do, because we're working backwards. In the beginning, we did exactly that. That was actually from section 2.2 and 2.3. Gave you a function, position function. We took derivative, gave you velocity. Took the second derivative, gave you acceleration. Now, we're going to give you the acceleration, the second derivative, and with some initial conditions, I can get the velocity function back. And then once I got the velocity function, I can integrate that guy and get the position function back. We now can go in reverse. Does that make sense? Question. Speaking of that, oh, what a surprise. All right, a particle is moving with acceleration a of t equals 12t plus 2. Its position at time equals 0 is s of 0 equals 11. And its velocity at time equals 0 is v of 0 is equal to 9. I ask you one more hoop here. What is the position at time equals 6? T equals 6. So, here we go. As I was just mentioning, to get velocity, I have to integrate acceleration. And to get position, we call it the position function s of t. I have to integrate the velocity. So I'm going to start here. To get velocity function, I'm going to integrate the acceleration, which was given to me. 12t plus 2 dt, because t, time, is the variable with this stuff. Well, 12 is a constant. Leave it alone. The integral of t to the first power with respect to t, add 1 over add 1, gives you t squared over 2. Plus the integral of 2 with respect to t would be 2t and 1 big plus c. Cleaning it up, this tells me that my velocity is equal to 12 divided by 2 is 6, t squared plus 2t plus c. So to figure out what the exact velocity function is, I got to have the initial condition so I can solve for c. The initial condition on velocity is v of 0 equals 9. So v of 0, which will be equal to 6 times 0 squared, plus 2 times 0 plus c, that's going to be equal to 9. Love plugging in zeros, so they go away. This pretty much tells me that c equals 9, which tells me the velocity function is 6t squared plus 2t plus c, but c is 9, plus 9. There's the velocity function. That's not what they wanted. They want position. So to get position, I've got to integrate the velocity function with respect to t. So integrate 6t squared plus 2t plus 9 with respect to t. 6 is a constant, leave it alone. Integral of t squared, add 1 over add 1, would be t cubed over 3. Plus 2 is a constant. This officially is t to the first power, so to integrate t to the first, you add 1, t squared over the power 2. Plus the integral of 9 with respect to t would be 9t. And then, of course, every time you integrate, you get another plus c constant of integration. So this tells me my position function, as you clean it up, 3 goes in 6 2 times, so I get 2t cubed. Here the 2's cancel. Plus t squared plus 9t plus c. There is my position function. But once again, I got a big old plus c. So I have to have an initial condition for the position function. They told me s of 0 equals 11. So s of 0 would be 2 times 0 cubed plus 0 squared plus 9 times 0 plus c. That's equal to 11. Plugging in 0 in this example is awesome because it's a polynomial and 0 to any power 0. So, which tells me that c equals 11. Therefore, your position function s of t is 2t cubed plus t squared plus 9t plus c, but c is 11. That's awesome. But that's not the answer either. Always go back and make sure you answer the question. What was the question? We only had one question on this thing. What is the position at time equals 6? One more hoop to jump through. The question is position at time equals 6. What am I after? S of 6. That'll be 2 times 6 cubed plus 6 squared plus 9 times 6 plus 11. Time for the old handy dandy calculator now. So I end up getting 2 times 6 cubed plus 6 squared plus 9 times 6 plus 11, and I get 533. And 533 what? Well, in this example, they didn't tell me any units. Acceleration would have been something like feet per second squared. Velocity would have been feet per second, and position would be in feet. Or maybe acceleration would be centimeters per second squared, and velocity would be centimeters per second, and distance would be in centimeters. So all I know is this would be some kind of a distance, and I could use the famous arbitrary units, whether it be centimeters, meters, feet, inches, whatever. I don't know what they are. They didn't tell me that. But the answer for web work is 533. Does that make sense? All right. So let's see if we can't figure out some more physics problems. Here's one right off of web work. So here it is. A stone is thrown straight down from the edge of a roof, 725 feet above the ground, at a speed of 5 feet per second. Part A. Given the acceleration due to gravity is negative 32 feet per second squared, how high is the stone 2 seconds later? And right here, people look at this thing and go, I don't even know where to start. Well, this is a physics problem. You got to outthink the problem. All right. We're standing on the top of a roof, and we're going to throw a stone straight down and try to hit somebody in the head with it. I have no idea why, but we're on top of a roof, and we're throwing stones straight down. All right. The roof is 725 feet up in the air, and we initially throw the stone straight down at 5 feet per second. Let me stop there for a second and describe to you exactly what's going on. The 725, notice the units is in feet. And that is where the stone is right at the beginning before it started to move, right? These guys are initial conditions. That's the way you look at it. Initial conditions. Initial conditions. Which tells me this is a distance, position. S of 0. The position of the stone at time equals 0 is on top of the roof. 725 feet. Feet per second is a velocity. So the initial velocity as we throw the stone is 5 feet per second. And I think we must have just tossed it over the edge or something or other. 5 feet per second is not very fast. Does that make sense? That's my initial conditions. Now, what makes the stone speed up? Gravity. And that's it. Unless you put some kind of interesting little force function on this thing or some kind of a spin to it, all we got in terms of acceleration when we chunk stuff off of buildings is gravity. The acceleration function due to gravity is negative 32 feet per second squared. It's a function. It's a constant. Negative because gravity is pulling you down at 32 feet per second squared. It's a constant. So that is a function. What do I have to do to get velocity? See, last problem. What do I got to do to get the velocity if I know the acceleration? I integrate acceleration and it gives me velocity. Rules we have memorized now. So this would be the integral of negative 32 dt. What is the integral of negative 32 with respect to time? That's what the dt stands for. Negative 32t, every time you integrate, you got to put this, plus c. So I now know that the velocity is equal to negative 32t plus c. But I have an initial condition for velocity. V of 0 equals negative 32 times 0 plus c, and that's equal to 5 feet per second. Well, 32 times 0 is 0. Negative that's still 0, so c equals 5, which tells me my velocity equation is negative 32t plus 5. That's great, but that's half the battle. What do I got to do to get position? Position, called s of t, is the integral of velocity with respect to time. See previous problem. So this would be the integral of velocity, which is negative 32t plus 5 dt. So s of t would be equal to, negative 32 is a constant. This officially is t to the first power. What is the integral of t to the first power? Add 1 over add 1 would give you what? T squared over 2 plus integral of 5 with respect to t would be 5t. And of course you got to have a plus c because I integrated. Cleaning it up, this gives me s of t is equal to, 2 goes into negative 32, negative 16 times, t squared plus 5t plus c, and I have an initial condition for position. The initial condition for position was, right at the beginning, we were on top of a building which was 725 feet above the air. So s of 0 equals 725. Which means s of 0 equals negative 16 times 0 squared plus 5 times 0 plus c, and that's equal to 725. So c equals, because that's all 0, 725, which tells me my position function is negative 16t squared plus 5t plus c, which is 725. All that is so I can get a formula for velocity and I can get a formula for position. Now we can go and answer the questions. Okay? What was my first question here? There's still one. How high is the stone 2 seconds later? What am I after? Height is a distance or position. So for the answer for part A, and even though I ran out of room down here, here's the answer for part A. We want S of 2. That would be equal to negative 16 times 2 squared plus 5 times 2 plus 725. So S of 2 would be equal to, time for the old handy dandy calculator here, negative 16 times 2 squared plus 5 times 2 plus 725. I get 671 watt, because this is a word problem, and with word problems we expect to have units. This is a distance. Distance is measured in feet. There is the real answer for part A, but I had to use my equations. Does that make sense? Part B. At what time does the stone hit the ground? This is the kind of stuff we're going to hit you hard on the final exam, knowing what to do. What time? What am I looking for? T. So at the end of the day, I'm going to solve for T on something or other. Does that make sense? Stone hit ground. When the stone hits the ground, here's ground level over here. When the stone hits the ground, what's the height? So stone hits the ground means the height or position is equal to 0. Height, which is your position, equals 0. So it becomes an algebra question now, but you had to go get the height equation. So S of t is equal to negative 16t squared plus 5t plus 725, and we're going to set it equal to 0. How are you at factoring? Because it's a quadratic. Negative 16t squared plus 5t plus 725. Set it equal to 0 and solve. Well, I don't think it's going to factor. Well, don't worry. If it doesn't factor, what do we have in our arsenals from high school or junior high school, actually? Quadratic formula. Solving for it, t equals, remember your formula, sing along if you know it, negative b plus or minus the square root of b squared minus 4ac all over 2a. Just to remind you, this is a web work problem, so enjoy. So here, a is equal to negative 16, b equals 5, and c is equal to 725. So t equals negative b, which is negative 5, plus or minus the square root of 5b squared minus 4 times a, which is negative 16, times c, which is 725, all over 2 times a, which is negative 16. This gives you negative 5 plus or minus the square root of, okay, I'm going to go ahead and cheat a little bit with the old calculator here. 5 squared is 25 minus 4 times negative 16 times 725, close the parenthesis there, and I get awesome 46,425 divided by negative 32. So what is the square root of 46,425? Crappy answer. All right, so there are 2 answers to this problem. What are my 2 answers? Negative 5 plus the square root of 46,425 divided by negative 32. And the answer is negative 5 minus the square root of 46,425 divided by negative 32. Just be careful on the old parentheses here. So the parentheses are in your numerator. Negative 5 plus the square root of 46,425 over arrow, closed parentheses for the numerator, divided by negative 32. I got negative 6.577019196 seconds. And then all I'm going to do is recall this thing down. It's the same thing except change the plus to a minus, and I get 6.8895191196 seconds. What's the answer? Well, this you have to look at in the context of the problem. At time equals 0 is when we started throwing things off the building to hit people in the head. So negative time officially is when we were actually walking, doing just before we committed the crime, walking up the stairs of the building and stuff like that. Negative time in the context of the problem is meaningless. Certain problems, negative time is meaningless. You start time equals 0. Negative time was when something happened before, and that may be important, like with those Newton's law of cooling problems, and when the crime was committed, when they had normal body temperature type stuff. So sometimes negative time is important, but not in this example. So get rid of the negative time here. The answer is this is web work, so no rounding. 6.8895191996 seconds. That is when the ball, or the rock, or whatever it was, stone hit the ground. Does that make sense? One more question. What is the velocity when the stone hit the ground? Now, this is an important concept here. You have to get part A to get part B. The question is, and I'll blow it up for you people in the back down there, what is the velocity when the stone hits the ground? I want to know that initial impact. Okay, that's what I want to know. And let's say we threw the stone off the roof and whatever. I want to know, hit somebody in the head. At what velocity did it actually hit him in the head? I want to know what this stuff is. Does this make sense? Very physics oriented. But to be able to know the velocity, the question is what's the velocity? So with what's the velocity, I want my velocity equation. No problem. We went back and solved that sucker. That was negative 32t plus 5. You with me? However, to be able to know what velocity is based upon time. You have to know at what time in the life of the event that this thing occurred. Does that make sense? So, what is the velocity when the stone hit the ground? Well, to know this, you got to know when stone hit ground. Do you guys happen to know when the stone hit the ground? Sure, we just got it right here. We just solved that. T equals 6.8895191996. There's the time when the stone hit the ground. Does that make sense? So remember this, because sometimes they ask you what was the velocity when the stone hit the ground, and yet they don't ask you to go when did the stone hit the ground. You actually have to find that information out first. So to get the answer, it'll be V of T equals 6.8895191996, which will be negative 32 times 6.8895191996 plus 5. Oh, that's a typo. I made a mistake. I made a big mistake. And that's going to screw up all my answers. Man. Okay. Let me go back. Let me fix my problem. I should have known this. What did I write down in the beginning? Here's my typo. A stone is thrown straight down off a roof of 725 feet. You have a roof of 725 feet. What direction did we throw the stone? I didn't throw it up. I threw it down, and I wasn't paying attention. That right there is key. If you go down, what direction is that? The velocity is negative when you go down. So I can go back and fix this. So my initial velocity is negative. So this is good, but remember, this would be negative 5. So I can go back and fix this. So when I plug in 0, and that will be equal to negative 5, C would be negative 5. So this would be minus 5. Does that make sense? Now, my velocity is negative 32t minus 5. So I integrate it, that would be minus 5t. So that would be a minus 5t. Luckily, I plug in 0. So this is a negative 5t. So when I plug in that, it doesn't change the constant at all. That would just be negative. But it will affect this guy here. That is a minus 5t. So the answer for part A, because it was going down, this was my fault because I wasn't paying attention. Negative 16 times 2 times 2 squared minus 5 times 2, that changed, plus 725 is 651. 651 feet. That was my fault. But it also affects this one here. This will be minus. So B would be negative 5. This will be negative 5 squared. And that makes it plus 5. And it will change all my answers. That sucks. All right, so let's just do it this way. Negative 5 would be 5. That would be positive 5. Negative 5 quantity squared minus 4 times A, which is negative 16 times John, times negative 16 times C, which is 725 is negative B squared minus 4. Oh, luckily it didn't change that number at all. It just changed that dude right here to be positive. All right, let's see what happens. Here we go. Hopefully it won't change anything. It's just a sign change. It'll be 5 plus the square root of 46, 425, parentheses around your numerator, sorry about that, divided by negative 32. And I get a negative, here it comes, negative 6.8895191196. And when I change that minus, that plus to a minus, I get the actual answer, 6.5770191196. So the answer here, when does the actual stone hit the ground? It was at t equals 6.577, because it changed my signs there, 1019196. That was my fault, because I wasn't paying attention to that initial condition when going down. So now, when does the stone hit the ground? At 6.577019196. So type in 0.5770. And here we go. Negative 32 times 6.577019196. And this will be minus 5 on my equation there. Minus 5. And what do I get for my initial velocity? Negative 215.4646143. Does everyone understand where my typo was at on this problem? It was at the beginning, because when we threw the stone, we threw it down. Down is a direction of negative. But I got a question for you. What is the velocity when the stone hit the ground? Negative 215.4646143 what? Feet per second. Do you understand 215.46 feet per second what that is? Well, let me just explain it to you. All right, I'm going to go under my apps button here, and I'm going to scroll down to Scientific Tools. Unit converter. This is a velocity, because I want you to understand this thing. This is negative 215.4646143 what? This was feet per second. Okay? To understand how much 215 feet per second is, I'm going to convert it to miles per hour. You understand? This is scientific notation. So in terms of converting it over, this is just for your benefit, I got negative 1.469 E2 miles per hour. What does E2 stand for? Times 10 to the second. Move the decimal place 2 places. It's negative because it's going down. 146.908 miles per hour. This is NASCAR speed. You understand? This is why when you go to places like downtown Charlotte or New York City or Atlanta or wherever where they have skyscrapers and stuff, it is big time illegal for you to throw anything off the top of these buildings. Because of gravity, I mean, it really, you will take like a stone and turn it into a rifle bullet. I mean, and if it hit somebody in the head, it would literally shoot right through them. This is why they have barricades up and stuff like that, and you're not allowed to actually go on the top of these skyscrapers and stuff, because if you do throw something that has a little bit of mass on it and stuff like that off the building, now yes, we can throw some physics in here about terminal velocity, air resistance and stuff like that, but by the time that sucker still gets to the ground, it's like a rifle shot, and it will kill people if they're walking along the street. I mean, yeah, granted, you've seen the Three Stooges and somebody throwing a flower pot off a building. That's 15 feet in the air. Try, 150 or 1,500 feet in the air. That's different. When that hits the ground, it'll shoot right through them. I mean, they've done experiments and stuff like that. They've thrown pennies off of some of these skyscrapers and stuff, and it embeds in the concrete about 1.5 feet. Okay. Don't throw crap off of buildings is what we're trying to tell you to do. It's great math, but there it is. Does this make sense? I mean, you guys are getting behind the physics of what we do and why math is so important. Well, congratulations. You have completed Calculus 1. Now we got to go through the test number 1. And so what I'll do is maybe we'll do on Thursday, we'll do some review, whatever questions you guys have. So I'm going to give you guys a gift. So if you come in on Thursday with your homework set and you got some questions on it, maybe we'll look at it first. Study hard, and I'll see you guys on Thursday.
Is there another